And if we solve this observation, we can find out the wave function of the oscillatory in nature. Okay, so sin kx n pi x by twice l. So depending on this length of this box, that will depend. Now the n equals to 1, usually we don't take we don't account for n equals to 0. Why? Because if we take n equals to 0, the sine term will be 0. So n equals to 0 term is not allowed, and also n equals to -1, -2, -3, they are not allowed, because if you see this energy, that is energy is equals to n square pi square h cross square by twice ml square. So if you just square it, so 1, if you square it, -1, it will be also 1, -2, it will be also, it will give you +4, -3, it will give you +9. So if you just take positive or negative, all represent the same energy. So basically you just need to account the n equals to 1, 2, 3, the discrete level of energies, right? So this discrete amount, that is the wave function, will be also according to the nature. That is, for the n equals to 1 state, the wave function will look like this. There will be no node in the wave function. For n equals to 2, there will be one node. Node means where the probability of psi being psi is 0. The n equals to 3, the wave function will take this. N equals to 4, the wave function will take this shape. So you can just see this graphic also. So the particle is moving inside this box, or this one-dimensional box potential, and you can see this wave function. Accordingly, it is changing. Now this is a question: can you physically interpret the wavelength of this wave function? For ground state, it is larger. If we go to the higher excited state, the wavelength gets smaller. Why is it so? Because